Hi, everybody. Welcome to an introduction to Elixir. My name is Erik, and in the next 20 to 25 minutes, we'll take you on a tour and show you why Elixir is a great language, some of its history, and we'll show you a live coding sample where we're solving an exercise in Elixir and showing off some of its features. We'll end it with some resources that you can use to learn Elixir, and I'm incredibly excited, so I hope you are too. So let's get started. Elixir has been designed by José Valim. José Valim was a core contributor to the Ruby on Rails team when he decided he wanted to try something else, and he wanted to build a functional language on the Beam VM. You might know the Beam VM from Erlang, which runs on the Beam VM, and its massively concurrent features where you can execute tons of things at the same time, all while still having great performance. And that performance is actually one of the goals of Elixir, to build something that scales really well. The syntax of Elixir is inspired by Ruby and a bit of Erlang and Clojure mixed in, but it's mostly very reminiscent to Ruby code, which makes sense as José Valim was a Ruby on Rails contributor. You also see the Ruby influence in its dynamic nature. Many functional languages are statically compiled, like a Haskell and F# or Scala, but Elixir is actually dynamically typed, which means that you don't get the compile time checks, but you get the runtime checks. And this makes it gives it a similar feel to Ruby, which is also a dynamic language. So they should have that in common. Let's go into why I think Elixir is a great language. First of all, I really like its syntax. It has been inspired by Ruby, and Ruby is famous for having syntax that's easy to work with, pleasant to work with. So you get that too with Elixir, where you feel like, oh, this syntax is just easy to write, it's easy to read, it's not hard to memorize, there are just a couple of rules. It's just really pleasant to work with, and that's very important for a language. So syntax, great. What I also love is that it has a great interop story with Erlang. So as told, the Elixir language runs on the Beam VM, and Erlang also runs on the Beam VM. So there has already been a lot of stuff that was written for Erlang, but you can use all of that seamlessly in Elixir. So you get everything written in Erlang basically for free for you. So that is a great thing where you nicely integrate with other languages on the Beam VM. And speaking of the Beam VM, which gives you a lot of fault tolerancy, and Elixir makes full use of that. So you can have applications that spawn I don't know how many processes and still have them be fault tolerant. So if some of them are misbehaving, they're erroring, they're crashing, you just have something that looks at it like a supervisor, will restart it, etc. So you can very, very finely tune your fault tolerance, and the let it crash mode of Erlang is you can really apply that to Elixir too. So you get all this fault tolerance goodness of the Beam VM, and that makes it really, really pleasant to work with. Mix tool, which we haven't yet discussed, is what you get when you install Elixir, and it is it's several things at once. It's a build system. It handles dependencies. It can do formatting for you. It can call the compiler. So it's basically an all-in-one package. So when you install Elixir, that's the only thing that you need to install. You don't need to install all these additional tools and things to handle formatting or build tools. It's just all there for you in the mix command, which is a great way. And especially if you're new to the language, it's always good that you don't have to install all these things because you have to know where to get it. You now don't have to. You just get everything in your Elixir installation. Speaking of tooling, the tooling in IDEs is also very good. So I've used the Visual Studio Code Elixir plugin, and it's really good. It gives you code completion, syntax highlighting, everything that you come to expect from a good IDE, and it works really well and really fast too. So excellent experience working in IDEs with Elixir. What I personally really love is that there's just a nice mixture of sweet syntactic sugar mixed in. So syntactic sugar are things that mostly they're shorter ways to write things, whereas underneath they'll compile to something else, or they'll be translated to something else in this case. But it makes it just using the language a little bit easier. And good examples of that are the with statement, where you can do consecutive pattern matching, and then you have an else clause. If some of the patterns don't match, you have list comprehensions, which are a great way of creating lists in a very declarative way. And another is that there is a shorthand syntax for anonymous functions, which in a functional language, you often use anonymous functions, passing them into other higher order functions that are built into the language. And there's a nice shorthand syntax with the ampersand sign that just makes it really short and easy to use. And I love those syntactic sugar things. They don't go overboard with the syntactic sugar, but they have this nice mixture of a bit of syntactic sugar sprinkled in. I love it. And then finally, what I find really cool is that Elixir has a concept that's called bit strings, which is basically dealing with bits and bytes in a very nice way. And you can even do pattern matching on it. And it took some time for me to get used to it. Once you get used to doing pattern matching on bits and bytes, it feels very natural to me. So you can treat strings like a sequence of bits and bytes. You can work with binaries, etc. There's all sorts of really nice pattern matching stuff that you can do, and it's really pleasant to work with, and a very cool feature of Elixir. We've just discussed some of the things that I really like about Elixir, but let's dive a bit deeper into some of what I feel its standout features that really set it apart from other languages. Well, first is the Stelle concurrency. So it comes from running on the Beam VM. So Erlang gets that too, but it's just, you can't even compare it to other languages in many cases. It's just the way that you can easily set up, I don't know, millions of actors all working in parallel while the Beam VM doesn't even really care. It's just the performance is so great, and you can scale to heights that you can't even imagine in doing it in other languages without a lot of hard work, and you get it for free. And it's so easy to do, and that's the thing. So you can do concurrency in other languages too, but with the Beam VM and Elixir, it becomes really easy to do it, and that's just mind-blowing at first. And once you get used to that, this whole way of structuring your application in lots of tiny processes, also called agents, it's just fantastic working with. A second feature that Elixir is very good at is its meta programming. So Elixir has macros, and with those macros, you can basically you can take code and you can generate new code. So you can do a lot of tweaks. You can generate things. There's a lot of stuff that you can do with macros, and it's really powerful. But not only is it powerful, if you combine it with Elixir's pattern matching features, which are great, we'll come to that in a second, it's really surprisingly easy to write these macros, because macros can be hard, but I felt like Elixir hits the sweet spot where the macros are still quite readable, and they have good documentation. Elixir has good documentation in general, which is the next point. But for macros, it's very important that you can still read the code, so that it doesn't become too hard. So everybody should be able to understand what is happening, or at least if you've got a basic familiarity with the macros. And I think Elixir does that really well. As said, documentation is great. So everything in the standard library is documented well, but Elixir has something on their homepage where it says documentation is a first-class citizen. And you might be wondering, what is that about? Well, you can do a lot of stuff with documentation. So not only can you generate documentation based on the docs within your code, so that's a very cool feature. But you can also actually have examples in your comments. So you have a method that takes, I don't know, an input parameter and returns something. You can have an example. If you call it with this, then you get returned this. But that's actually executable. So you can instruct your unit test to also run the tests within your comments. These are called doc tests. So you have you can have examples in your documentation, in your source code comments, and these will run when you run the test. And that's just incredibly useful, because it's always a good thing to add examples to your source code, but to even have them be running in the tests, that's just amazing. And I don't think many languages do that, and I really love that about Elixir. And then finally, what I really, really dig is its pervasive pattern matching. So pattern matching is everywhere. It's the default way that you deal with things. But what many functional programmers do, but only some of them also have, is where you can pattern match on a function definition level. So usually you define a function, and within the function you do pattern matching. But Elixir also allows you to do the pattern matching within the function declaration. So you can have a length method that works on an empty list, and you can have a length function that works on a non-empty list. But those will be like two different function definitions with the same name. So Elixir knows that they have the same name, so they're basically the same, but they have a specific order to them. So you can do the pattern matching within the function definition, and that's called multi-clause functions. And it takes some getting used to, at least to me. But once I got used to it, it was really, really cool, and I felt it was a really, really natural way of encoding these things at the function level instead of within the function. So I really enjoyed these multi-clause functions and the fact that you have pattern matching everywhere, and it's so powerful. I've talked quite a lot about Elixir. I think it's time that we see some actual Elixir code. So what I'll do is I've taken one of the exercises in the Elixir track, the series exercise, and we'll be solving this exercise step by step and showing you some features of Elixir along the way. So let's get started. The first thing that we did was we downloaded the series exercise, and if you don't know the exercise, what you get is you take a string and you get a number, and you then return all the slices, the series of that string. So if you have a string A, B, C, D, and you would return the slices of count 2, so that will be the second argument, and you get A, B, B, C, C, D. So it's like a sliding window. And that's it. That's the entirety of the exercise. So let's see how we can solve that in Elixir. Let's look at the stub file that we start out with. You can see that there's a thing called a module. It's called string series, and there is a function called slices within it. The slices function takes two parameters, a string parameter, and then the size of the slices that you need to return, which is an integer. The parameters are currently prefixed with an underscore to indicate that they're not used, which you can also see in the syntax highlighting. They're greenish, and if we remove the underscore, they become white. So now let's start to use them. The first thing that we need to consider is how do we get all the letters? So if we want to slice it, we want sub slices of the string. And one way that you can do that is by first converting the string to a list of letters within the string. But Elixir does things a bit differently than some other languages in that you can't just iterate over a string. You actually need to call them a function on the string to get the individual characters. We'll show you how by looking at the documentation. Let's look at the documentation for the string type. So we have the string documentation here. A lot of stuff here. You can see that it's really extensive. Check these. It's just so much going on. But what we are interested in are the letters. So you can see here there's a lot of stuff about encoding, UDF-8, blah, blah, blah. But what we are interested in is the grapheme clusters. So there's a couple of methods that you can use on the string. But strings to Elixir are basically sequences of bits. To get individual letters, there is a couple of methods that you can use. You can use string.codePoints, and you can see that doing that on a string that contains an E with the dash on it, you get an E and then a second character. But what we want is we want that character. So most of the time when you're working with letters, you probably want graphemes. So we can use string.graphemes. So let's go back to Visual Studio Code, and we'll do string dot, and then we get nice IntelliSense here. We're using string.graphemes. It takes a string. You can see here that it returns a list of graphemes. So we'll pass in the string. We'll assign that value to a graphemes variable. Okay, that's good. So that's the first step. Then the second step is that we have a list of characters and then want to take those slices. Well, the best thing to do is to look at the enum module. So we could go to documentation. We could also try and see if there's anything here that we like. And as it turns out, there is a function called chunk average, and there are two versions. So one takes 3 arguments and one takes 4. So let's do the second one. So you pass in an enumerable, and the list is an enumerable. So we can pass in the graphemes. And then the second argument is the count. So this is how big the chunks need to be. Well, this is the parameter that gets passed in, so the size. So what are the other arguments? So we can do a third argument, and that's called step. And this means that it starts at the beginning of the enumerable. It will return size elements, the first size elements. And then if you try and get the next one, how much do you progress within the list? So what we want is, as you remember, A, B, C, D would be A, B, and then B, C. So that's a step of 1. So our step is 1. And we'll disregard the last one for now. We'll come back to it later. So, but these are we could say these are the slices. We could say these are the grapheme slices. That would be best. So grapheme slices is now a list of graphemes, but what we need to return is a list of strings. It's actually a list of graphemes. So we have to somehow get these grapheme lists into a string. So that sounds like a map to me. Map takes an enumerable and then a function that you pass in that transforms each element within the enumerable. So we'll pass in grapheme slices, and then we'll do, we have to pass in a function, and we can do an anonymous function like this. So we'll do fun, and then this is a grapheme slice, and then we'll somehow make it into a string. And it turns out we can use to string on the grapheme slice, and then end it, and this should be the slices. So we can return this and see if this actually does anything. Okay, so that's good. This works, so we can skip this intermediate variable, and this is all very nice. Let's try and see if it works for everything. So we'll just uncomment the other skip bits, and this will run all the tests. So almost everything works now, except for this slices with same size as string. So you can see here that this is a string with 5 characters, and we want to return a slice of 5 characters, but it actually returns slices of 5 characters and 4. And there's actually a fourth argument, which I briefly mentioned, where you can say, hey, if I pass in colon discard, it will mean that the chunk every function will only return slices, chunks that have this size. So if it's less than that, it will discard it. So run it again. That should, we only have one failure now, so that's great. So the final failure that we have is, let's see, a lot of information here. Test slices with size 0 or negative returns empty list. Okay, so if the size is 0 or a negative list, so you might be thinking that, hey, we do an if statement here, but that's an option, but it's not the typical Elixir way. So what you usually would do is you'd say this is like a special case. So what we can do is we can do this. We can define the function again, same syntax, but now we add a guard clause. So we're saying if size is less than 1, then we return an empty list. So that's in the spec. So this is multiple clauses. And the way this works is that when this is run, so when somebody calls the slices function with the 2 arguments, it will evaluate things from top to bottom. So it will evaluate this first, and if this has two parameters and this matches, then it will execute this code. So if the size is greater or equal to 1, it will run this code. Otherwise, it will run this code. So theoretically, we should now have passing tests. And we do. So that's really nice. And this is an example of the multi-clause functions that I mentioned before. And it's a very natural way if you do this a couple of times, because none of this has to be indented for a special case. You just have a different function that you can work with. And I really like that this reduces indentation. It also gives you a visual way of seeing that this is an exceptional case. So that's, to me, that's brilliant. So to top everything off, let's do some refactoring. So the first thing that we can do is, this is a lot of lines of code for just a simple return. There's actually a bit of syntactic sugar that you can use. What you can do is you can do, if there's just a little bit of code that you want to do within the function, you can change it to a comma, do, colon, and then remove the rest, and that should still work. So this is I especially like this if there's just a very simple expression that you return. Another thing that we can do is this function definition is basically all it's doing is it has a function with one argument and it passes it on to another function. And there's a shorthand syntax for that. So what we can do is we can do ampersand to string, and then there's this magic variable for each of the arguments. So the first argument is ampersand1, and we only have one. So this is it. So you can do this. You're saying, hey, this is an anonymous function that calls toString with the first argument. And you can do this for functions with multiple arguments too. Then you would have ampersand1, ampersand2, etc. So run it again. Works. Okay, cool. A common pattern in Elixir is you see here we're doing function call, and on the result of the function we do something else, and then on the result of that function we again do something else. You can see here the graph is always the first thing that gets passed into the next one. The graph slice is the first thing. If that is the case, what you can do is to use the pipe operator. And the pipe operator may be familiar if you've done F# or camel. So what you can do is you can say, hey, s, and then pipe it into a function. So we'll pipe it into string.graphthemes. So this is exactly the same as doing this. It's just a different way of writing it. And it shows you a bit of, it will become better if we chain this. So instead of having these the graph themes passing in via the function call, we'll remove it here and we'll use the pipe operator. So what we're saying now, first pass in the string to the graph themes. This will return the graph themes. Then we'll pass in the graph themes into this call at the first position. And then the result of that, we'll pipe it into enum.map. So this is the same thing. It runs the same thing that we did previously. So run it and it works. But I like this quite a bit because it stresses to me that this is like a pipeline. This is data that's going to be processed one by one. And I quite like this. Whether or not you do, I don't know, but I do. So the last thing that I wanted to show you is the doc test. So we can add another section here, and we'll do 1, 2, 3, 4, and we'll say IEX, which is the interactive, like the REPL of Elixir. And then you can have a function call here. So we'll do string series.slices, which is our function. So let's do ABCD and have a slice length of 2. Okay, so what this should return is a list of AB, BC, CD. And let's see if we can get our tests to run this. And to do that, we'll have doc test and then the name of our module, which was string series. Then run our tests. And you can see here, there's a doc test string series.slices. You might think, is it really executing it? Well, let's test. We'll do CDE. And you can see here, now it's failing. So you can see that the Elixir test framework was able to parse this into an actual unit test. So I think that's fantastic, and I hope you think so too. And I encourage you to play with it. So I'm now quite happy with this, how it looks. I hope you are too. And if not, you can try it your own by going to the Elixir track and trying out this series exercise. We'll finish things off with some resources that you can use if you want to learn Elixir, and I hope you do. My totally unbiased opinion is that the Elixir track on Exercism is the best way that you can learn Elixir. And there's a couple of reasons for this. For one, it has so much content. There are over 150 exercises that you can do. But not only that, more than a third of those are learning mode exercises. Elixir has a learning mode. It has a syllabus where you can progress through all the Elixir concepts one by one in a very natural way. So there is a really nice progression in the concepts where you slowly build up your Elixir knowledge. So the progression is great, but the exercises are great too. So they are very focused. They just teach you one, maybe two things at most. So you can just focus on that one thing and really get to grasp with it. And then I think if you progress through all those learning mode exercises, you'll have quite a firm grasp of the basics of Elixir and some of even more advanced stuff like macros and agents, etc. And once you get to that point, I think the other 100 exercises are a great way to further hone your Elixir skills. So you can be doing Elixir for the rest of the year, I think, just by the amount of content that there is. And it's a great way to get started with the language. So it's an exemplar learning mode track. Another resource that you can use is the official Elixir introductions. Introduction can be a bit boring at times, but I don't think this one is. So the Elixir introduction is quite extensive, but it's really engaging. So there is so much code content that you can also follow along. It takes you on a journey that takes you via most of the language constructs that you can use, and it's done really well. It's written well. So I had a lot of value by reading these chapters in the Elixir introduction, which is extensive, more extensive than the average introduction is, and it's a great learning resource. And then finally, when you're doing Elixir, you want to interact with the standard library because that's where all the goodness of the functions that you can use is. And the documentation, as I mentioned, is a first-class citizen in Elixir, and you can really tell that they've given documentation a lot of attention. So the documentation is excellent. Functions have proper descriptions, the parameters are well described, but also there are so many code examples, and that especially really helped me personally to understand what the function does. So there's so much to learn just by looking at the documentation, and I would highly recommend you always keeping this open in a tab when you're doing Elixir because it's great. And in your IDE might even have code completion, by the way, where you get the same information within your IDE if you're using VS Code, for example. I hope this has been a useful introduction to Elixir and that you're now really excited to try out the language. I have enjoyed Elixir a lot, and I hope and I expect you will too. So give it a try. And thanks for watching.